everything I haven't tried to make this all mine. Pushing fast for the light.
Ashwin, there's no audio on the YouTube page. You can just confirm that.
Okay.
I think we can now begin, Mukul. The audio is now all corrected.
Yeah, sorry for the inconvenience.
Shall we start then?
Yeah, good to go.
All right, okay. Okay, Mayank, thank you. Thank you so much. So I'll just, yeah. Okay. Good evening, everyone. So today we have with us one of the more prominent advocates of Tensorflow JS, a senior developer at Google, someone who correctly describes himself as a hybrid developer who enjoys both creativity and technology and has made quite a name for himself in combining the two to bring out new innovations. Mr. Jason Myers has been working in Google for the past 9 years, where he has risen through the ranks from a web developer to being a senior developer for the technology giant. As one of the more prominent in the field of machine learning at Google, Mr. Jason Myers has advocated the use of TensorFlow, and his presentations on the same have certainly turned heads and made other technologists pay attention. In his spare time, he also consults on various web development projects, including providing technical consultancy to various firms. He graduated from the prestigious University of Bristol in 2008, where his final year project on mining was nominated for the coveted National SET Awards. We at IEEE are honored to have Mr. Jason Myers with us here today, who has agreed to tune in all the way from San Francisco, and despite the time differences related issues, has taken out time from his schedule to deliver this webinar here today. I am sure that I speak for all the audience tuning in right now that we all have been looking forward to your session, sir, at the first ever virtual IEEE Chandigarh Subsection Congress. So without any further delay, I would now like to invite Mr. Myers to start off with this lecture. Welcome, sir. Handing over to you.
Cool. Thank you very much. And thank you for having me. It's exciting to be here today to talk to you all. So I'm just going to go and share my screen. One moment. Okay, so hopefully everyone can now see my screen. So yes, I'm Jason Mays. I am the developer advocate for TensorFlow JS here at Google. And that basically means if you're using machine learning in JavaScript out in the wild somewhere, there's a good chance that our paths will cross at some point in the future. Now, being a developer advocate basically means I put myself in the same trenches as you guys and girls to code alongside you to make sure the developer experience is as good as it can be. And of course, do presentations like this as well. So very quickly, I just want to cover a little bit about who I am and why I ended up doing what I do. Essentially, if there's one thing you take away from this slide, this is my career history to date, is that I've been using JavaScript for pretty much half my life. I started out as a computer scientist, moved into web engineering, and then decided to go full stack web engineering so that I could get UX design, front-end skills as well. And then later in my Google career, I merged into being a creative technologist or creative engineer, which allowed me to do lots of cool prototyping for some of our largest brands that we work with at Google. And you can see some of those demos on the slide right now. And then finally, I found the TensorFlow.js team, which needed the background in web engineering, but also an interest in machine learning as well, which allowed me to combine both of my passions into one job. But why would you want to do machine learning in JavaScript? And this is an excellent question. First of all, you can use machine learning in JavaScript anywhere JavaScript can run. So that could be in the web browser, on the server side, desktop, mobile, and even Internet of Things. And if we dive into each one of these areas in more detail, you can see many of the technologies you know and love already. So we support all the popular browsers that are out there right now. On the server side, we support Node.js. On mobile, we support React Native, WeChat, and progressive web apps. On desktop, Electron for desktop native apps, and of course, Raspberry Pi for Internet of Things via Node. And JavaScript is one of the only languages that can run across all of these platforms without additional plugins and so on and so forth. So that alone is a great reason to consider using machine learning in JavaScript. And TensorFlow JS allows you to run, retrain via transfer learning, and of course, write machine learning algorithms completely from scratch if you so desire. And this is basically the same as what you could do in Python, but in JavaScript, of course. So with that, this allows you to dream up pretty much anything you may want. Augmented reality, sound recognition, conversational AI, all of the things you may have heard about in machine learning can now be done in JavaScript as well. And we're going to see more of those in detail in just a second. Now, there's 3 ways you can use TensorFlow JS, and I'm going to go through each one of them right now. And depending on your background in machine learning, you may want to choose one over the other to get started. Now, first of all, we have our pre-trained models. Essentially, these are really easy to use JavaScript classes for many common use cases. In fact, we have several of these already available, and these are available on our GitHub, which I'll give links to later in the presentation. But things like object detection, body segmentation, which allows you to find which pixels in an image belong to the human body and which are the background, pose estimation to estimate where your skeleton is, and much, much more. In fact, some of our newer models, such as face mesh, hand pose, and BERT Q&A are super powerful for understanding the human face, hands, and of course, natural language processing in the web browser. So let's take a look at some of these right now to get a better feel for some of these easy to use JavaScript classes that you can use even with almost zero machine learning experience. Now, the first one I want to talk about is object recognition. This is actually using Cocoa SSD behind the scenes, and it's been trained on 90 object classes. And you can see here, it gives you the bounding box of the objects it finds in a given image, as you can see on the right-hand side. Now, the cool thing about this is that you get that bounding box back. So not only do you know that the object exists in the image, but you also can understand its location. Now, this is different to image recognition, which will tell you that an object exists, but it won't tell you where. So object recognition is actually very, very powerful here. So let's go ahead and see this in action, just to kind of illustrate this further and how well it works in the web browser. So if I share my tab here, you can now see a web page that I've created. And once again, these links will be at the end of the show. And I can click on any one of these images, and as soon as I click, I get the classifications coming back. And you can see on the right-hand side, it's even able to handle multiple objects at the same time, like these 2 humans and the dog. But we can go further, of course. If I can classify an image, I can, of course, classify many images at the same time. And here I am live in the webcam right now. Hello. And you can see it's classifying me as a person with 90% confidence, which is reassuring that I am a human. And you can see me in my bedroom as I move around, all in real time. So you can see the performance is actually really, really, really good. And with this, if you can classify an object, you can make some really cool things. So back to the presentation. There we go. Let's talk about some of the other models as well. So face mesh is just 3 megabytes in size, and it can recognize 468 unique facial landmarks on the human face. Now you can see from the animation on the left how robust that is, but you can actually use this in very creative ways. And in fact, Modiface, who's part of the L'Oreal group, have actually used face mesh in the web browser to allow virtual makeup try-on. So the lady on the right-hand side here is not actually wearing any lipstick. We're using WebGL shaders combined with face mesh to allow her to try on lipstick before she's even purchased it to see what it might look on her. So this is a cool demo, but let's see the demo live in action, of course, because why not? So I'm going to go and share my other tab here. And now you can hopefully see on the screen that it's rendering my face in real time with the mesh. And because this is JavaScript, not only are we doing the machine learning on the left-hand side, but on the right-hand side, I'm able to render this 3D point cloud using 3.js, which is very, very powerful. And of course, the reason I bring this up is that JavaScript is very mature for graphics and the presentation of information, much more so than other languages, in fact. From day one, JavaScript has had to deal with the presentation of information. That's what the internet was basically designed to do. So we've got some very rich libraries, and you can make demos like this in well under a day if you wanted to do so using our face mesh models. So back to the presentation. There we go. So all of these demos can be used, but you're about to see, can be created using body segmentation too. And this allows you to identify 24 unique body areas across multiple bodies all in real time. You can see this in the animation on the slide. As it's kind of small in my bedroom right now, it's better to look at the slide for this one, but you can see how well it segments people when all the settings are maxed out. And you can even get the pose estimation coming back to understand where the human skeleton is. So you can imagine if you understand where the pose is, you could then recognize gestures or whatever you so desire. So with a bit of creativity and imagination, I just want to show you a couple of prototypes I've created using body segmentation just for inspiration. So you can use this in really delightful ways, and I encourage all of you to start thinking outside of the box. If you can understand where the human body is, you can also understand where the human body is not. And in my first demo on the left-hand side, you can see how I remove myself from the webcam in real time, all in the web browser using JavaScript. And you can see as I go in my bed, the bed still moves, but I am removed in this middle image. And of course, it's not quite perfect. There's a few glitches here and there, but consider, this can be perfected with more training data and so on and so forth. Now note how this effect is more complex than just replacing the background with a static image. Of course, you could do that and that would achieve similar results. However, if I got on the bed would never change. And notice how as I get on the bed deforms, even though I am not shown. So you get this very cool live effect, which is kind of very like Harry Potter or something with invisibility cloak. And it's a pretty cool effect. Now I made this in just one day. So that just shows how fast you can prototype in JavaScript using our machine learning models. On the right-hand side, you can actually see another prototype I created. Now, I don't know about you guys, but I really am terrible at buying clothes. I never know what size I am when I'm trying to order clothes online. So I decided to use the same model, body pics, to essentially figure out my key clothing size measurements, such as my chest, my inner leg and waist, and those kinds of things. And using that data, I can then correlate that with a brand's kind of clothing measurement sizes and determine if I should be a small, medium, or large on that website in under 15 seconds, which is pretty cool. So often, if you think about a problem you have in your daily life, you can maybe solve it with something like Tensorflow JS too. And of course, this can go even further to give you superpowers. As you can see on this slide, this is actually made by one of our community members. This guy from the USA combined it with WebGL shaders. This is using our face mesh model. And from that, he can determine where his eyes and mouth are, which then allows him to shoot these kind of rays from his eyes and mouth all in real time, making you look like Iron Man. And of course, this runs really smooth in the web browser, as you can see. But you can go even further. What about all the other emerging technologies that are coming out right now? We have things like WebXR for mixed reality, WebGL for 3D, and of course, Tensorflow JS. And you combine all of those, and this guy from Paris is able to scan any magazine, and if that magazine contains a photo of a person, we can then extract that person and bring them into our living room and walk up to them in real life, which is really, really cool. It's a very fun way to experience this. So the second method I want to talk about is transfer learning. Now, of course, if you are very familiar with machine learning already, you can use our APIs to code this yourself and manually access the layers in the model and use the layers to then build something else. However, essentially transfer learning is the process of retraining your models to work with your own data. And that can give you some performance benefits for taking less time to do so. And I want to talk about two ways you can get started if you're newer to machine learning or maybe even newer to JavaScript, that are very easy to use. Now, the first one is Teachable Machine. Teachable Machine is a website produced by Google that allows you to train on stuff from your webcam, such as the microphone or the webcam image itself, in a very easy manner. In fact, it's so easy, I'm going to show you right now how to use this. And hopefully, at the end of this presentation, everyone on this call can make something that recognizes an object in their bedroom. So if we click on, you can see here, if you come to Teachable Machine, just Google this, you'll find this landing page. And right now we support three examples, one to recognize objects, one to recognize audio, and one to recognize poses. For this session, we're just going to recognize an image. So let's go here. So once you click on that, you're going to be presented with this screen. Now, the first thing I'm going to recognize is myself. So I'm going to put this class as Jason. I'm going to click on webcam, and now you can see me live in this view here. I'm just going to click on hold to record and move my head around a little bit to get some variety. And you can see I've recorded roughly 43 images of myself. I'm now going to go to class 2, and I'm going to put a deck of cards as the second thing I want to classify, as I've got some handy here. We then click on the webcam button for class 2, and we're going to do the same thing, but record about 42 images of those as well. And there's roughly 42 images, okay, 45, that'll do. Now we've got some training data. We can click on train model, and notice this is all happening in the web browser, which is really cool because that means none of your data is ever being sent to a third-party server for training or classification. So that's very powerful. And as you can see, in under 30 seconds, we've now got the model retrained with our custom data, and you can see a live preview of how this is going to act in the browser. And this is all in JavaScript. And if you see on the right-hand side here, it's predicting the current frame as Jason, which is correct. I'm currently in the frame. But if I hold up my deck of cards, you can see it now changes the prediction to cards. Jason, cards. And see how easy that was to do and how performant it is. Instantaneously, it changes to the right thing. Now, of course, this is great for prototyping. And if you want to do more robust things, I'll show you how to do that in just a second. And there's one thing to be aware of course, if you're doing stuff in the web browser, you are limited to the amount of RAM that Chrome, Firefox, etc. will allocate to a given tab. So for small little prototypes like this could be great to control your garage door in your house if you want to check if it's been left open or not, and then automatically close it with a Raspberry Pi or something like this. You could make something simple for your use case very easily using Teachable Machine. Now, if you like what you've created and it works well enough for your needs, you can click on Export Model at the top right here, and this will essentially allow you to export the model and download it so you can host it on your website. It's just a JSON file with some extra files it uses to download. And then you can use that code on your website to then recognize the thing you trained it to learn. And then, of course, you can add your own user interface and make it do something useful other than just predict in the browser, as you see here. So going back to the slides, the second thing I want to talk about is Cloud AutoML. So if you want to make a production quality system, something you might deploy to the real world at scale, and not just for a very niche use case like we saw here, you can do this with Cloud AutoML, and this supports exporting to Tensorflow JS as well. So you can see here, someone was trying to understand all these different flower types. So all they've done is they've uploaded maybe gigabytes of images of different types of flowers and different folders to Cloud AutoML, as you can see on this page. And then once you've done that, you can simply specify you want to train for higher accuracy, a trade-off, or faster predictions. And you can choose, based on your use case, which is more useful to you. Would you rather have it be faster or have higher accuracy? This is always a trade-off we make in machine learning generally. And once you've done that, you wait a few hours for Google to do its thing, and it will go away and it will try hundreds of different models with different hyperparameters to find the best model possible that can work with the data that you've given it. And a few hours later, it will come back and be like, hey, I finished, here's the results. And you can then click on Export to TensorFlow JS at the very end here. And once again, that will just give you the JSON file that you need to host on your own website to then be able to use that trained model. And you might be asking, well, how hard is it to use all this stuff? Well, actually, it's super easy. In just 3 lines of JavaScript, as you see here, we're able to do this. So let me just walk you through this code to use Cloud AutoML. So at the top here, we just have some script tags to import the library for TensorFlow JS and the library for AutoML. I then got this image tag, which is representative of a new image that we've never seen before. This is just an image from the internet that I want to classify as a test. This could be image from your webcam. It could be anything. And then here's the actual JavaScript just below. We've got 3 lines of JavaScript. So first of all, we load the model. We call tf.automl.load image classification, and we just simply pass in the JSON file that we downloaded from the previous step. So this will be hosted on your web server somewhere, which you downloaded from the previous step. And we await for that to come back, and we assign it to this constant model. And we use the await keyword because this is an asynchronous operation, which means it will take some time to execute, and we don't know how long it's going to take. So it automatically will populate when it's ready. Once model is populated, we can then get a reference to the image we want to classify. So here, document.getElement by ID Daisy is just simply referencing this image we have above, which has the ID of Daisy. And we assign that to image. And then finally, we simply await model.classify, and we pass the image we want to classify. And that will then come back with predictions, which is simply a JSON object with all the things we think we can see in the given image that you sent to be classified. And of course, you can call classify multiple times, and that's how you would work with a webcam. You just call it every time the browser is ready and is finished some work. You can then redo the classification on a new image from the webcam, and that's how you can do things in real time, okay? So in just 3 lines of JavaScript, you can get this stuff working, and it's super powerful. You can then deploy this at scale and make very useful things for your customers and clients. Now, of course, the third way to use Tensorflow JS is to write your own code. And this is for people who are more experts in machine learning. And of course, if you've done that, you're probably more familiar with Python in the past. But of course, as you now know, you can do the same things in JavaScript. Now, if you are familiar with machine learning already, there's a good chance you know how to code and the APIs and so on already. So I'm not going to go into that. I'm going to focus on the superpowers and performance benefits you can get by using Node.js or JavaScript. So first of all, Tensorflow JS has 2 APIs. There's a high-level API called our layers API that's very similar to Keras if you've used Python before. So if you're familiar with Keras, actually, you'll be very much at home with our layers API. It's the same function definitions and so on and so forth. We also have the lower-level ops API, which is the more mathematical one that allows you to do all the linear algebra and all that kind of fun stuff if you want to go low-level, and that's very similar to the original TensorFlow API. Now, these basically get put together like this. So we have our ready-made models at the top there that sit upon our layers API, and our layers API sits upon our core or ops API. And then this can talk to different environments. On the client side, you might have things like the web browser, WeChat, React Native, and so on and so forth. And each one of these environments knows how to talk to different backends, which you see at the very bottom there. Now, all of these backends know how to talk to the CPU. This is like the fail-safe, that's always available. However, some environments also know how to talk to WebGL, which allows you to get graphics card acceleration across many devices, and also WASM, which is WebAssembly, for more consistent performance on CPU and better performance generally on the CPU if no graphics card is available. Now, on the server side, it's a similar story for Node.js, and there we support the TF-CPU and TF-GPU bindings exactly the same as Python does. So both Python and Node.js talk to the C bindings that TensorFlow is actually written in. So that means Node.js runs just as fast as Python does for model inference. And we'll see more on that in just a second. And then finally, I just want to point out that if you are preferring to use Python for your machine learning development, you can still use Python, but you can bring in those models that you make into Node.js for some performance benefits we'll see in just a second. So you can see here, we can import Keras models using our layers API. We can import TensorFlow save models using our core or ops API without conversion. So even though you've written it in Python and exported to save model format, Node.js, TensorFlow JS understands how to use that save model format directly, and you don't need to convert it in any way. Now, if you do want to use it on the client side, then you'll have to use our TensorFlow JS converter, which is a command line tool. And that allows you to take your Python saved model and use it in the web browser environment, essentially, okay? And that's just a command line tool you can run. And that's only required if you want to transfer a Python saved model to run on the client side in the browser. If you're running on Node.js, there's no need for that conversion. It runs straight away. And of course, if you're writing in TensorFlow JS from the beginning, there's no need to convert either because you're already writing in TensorFlow JS in JavaScript or Node. Cool. So let's talk about performance then. Here are the results. These are example results for MobileNet v2. And you can see here in Python, it is 7.98 milliseconds to do inference on a GTX 1080. And in Node.js, it's 8.81. So within margin of error, this is actually basically the same. And for all intents and purposes, there's negligible difference. Now, what gets really interesting, though, is that if you have a lot of pre or post-processing, you can actually get some performance benefits by running in Node.js. And often, for those of you who are new to machine learning, you need to massage your data into the correct format. Machine learning models only work with numeric data, for example, and you need to take that imagery or tabular data and convert it to a format that the machine learning model can digest. Now that's known as pre-processing, and sometimes there's even post-processing on the way out of the model as well. Now, if you run that in TensorFlow JS in Node, you can actually get benefits from the just-in-time compiler of JavaScript. And we've actually seen for Hugging Face, who are very popular for machine learning, for natural language processing, for their distill-BERT model that previously was written in Python, just by converting to Node.js, they saw a 2 times performance increase in speed by running it in Node.js, because that pre and post-processing got the benefit of the just-in-time compiler. So the inference was the same, but because of all that extra processing that needs to happen around the model itself, you can then leverage the just-in-time compiler to get those benefits, which is super cool. So I just want to talk about some of the superpowers you can get if you're using it on the client side, so client side being in the web browser. First of all, privacy. As I mentioned before, if you're running in the web browser, all of the data is being analyzed right on the client's machine. That means none of that data is sent to a third-party server for inference, and that means that privacy is preserved. That's really important in today's world where privacy is top of mind in many countries. And of course, if you're doing something in the medical industry or legal, so on and so forth, privacy might be a top priority too. And with TensorFlow JS, you get that for free. The second point is lower latency. Because there's no server involved, there's no round trip time to the server and back again. And on a mobile phone, that could be 100 milliseconds or more if you have a bad connection. That completely goes away if you're running directly on the mobile device. Third point, lower cost. Because you're not having to run machine learning servers 24/7, if you have a reasonably popular machine learning website, then you could be saving tens of thousands of dollars every month just by not having to run costly GPUs on the server to do that inference. And then the fourth point, interactivity. As you saw in the previous demos, JavaScript is great for interaction, for graphics, and all this fun stuff. There's tons of libraries that you can use, such as D3.js and all this kind of stuff, to do really advanced graphics and charting and so on and so forth. And then the fifth point, reach and scale. Anyone can open a link on the web browser, including my grandma, and you can get the machine learning for free. You don't have to be a machine learning expert to use and try that machine learning model, which is very powerful. So the same is not true if you're using Python. If you're using Python, the person who wants to try your code has to, first of all, install Linux on their machine if they don't have it already. They need to understand how to install TensorFlow along with the CUDA drivers and so on and so forth, which is not that easy. But then they have to clone your GitHub repository, and then they have to understand how to use your code. And let me tell you, it's not always easy to understand people's code that you've not seen before if it's not got a nice documentation. So you've got all these barriers to entry by doing this on the server side. And of course, if you're a researcher, maybe you just have a team of 5 people working on a very cool, new, innovative model. But if you can deploy that to the web, you can get 10,000 people to try it. And I guarantee the people in the real world will use it in ways you never imagined. Kind of like the examples you saw me create today, like invisibility. You know, I'm sure the people who made body pics were not expecting people to make themselves invisible using it. They thought, oh, if I can recognize body, they're going to be like talking about the body or showing things on the body, not removing the body. And of course, we'll find these edge cases. So with that, you can find biases or bugs in your model and have a chance to fix them before you go prime time. And of course, on that note of reach and scale, GPU support is on 84% of devices via WebGL, which is much better than on the server side, because in order to use Python TensorFlow JS on the graphics card, you need to use a CUDA library, which is only supporting NVIDIA. With TensorFlow JS on the client side, we can run on AMD, we can run on a MacBook Pro. All these devices that previously aren't supported can now be used for machine learning using JavaScript. Now, if we flip to the server side for a second, we can see the benefits for Node.js if you're running on the server side. First of all, you can use the TensorFlow save model without conversion. So if you do prefer to use Python for your machine learning training, you can still do so, but it allows you to integrate with web engineering teams to get more eyes on your model if you choose to do so. And that means a web engineering team who probably use Node.js, because I think 50% of developers use Node.js as their kind of stack right now. That means they can have a much easier time digesting your model and deploying it to the web. Secondly, you can run larger models than you can do on client side. Currently in the browser, there are limitations on how much RAM you can use. Of course, if you have your own server, it's up to you how much RAM you want to put on that server. The third point is it allows you to code in one language. If you already use JavaScript, and 67.8% of people do use JavaScript according to the 2019 Stack Overflow developer survey, that means you don't have to change and learn a new language. So if you are one of that 67.8%, that makes your life much, much easier. And then fourth, of course, there's a large NPM ecosystem, and that's continuously growing, so great community. And the fifth point, as we saw, we get those performance benefits from the just-in-time compiler that can give you boosts of up to 2 times more performance just by running your pre- and post-processing in Node.js. So with that, I want to end with resources, of course. Hopefully, these will allow you to take your first steps with ease. If there's one slide you want to screenshot today, I highly recommend this one right here. This has all the links you need to get started. First of all, our website and API for those of you who want to go deeper. We've got our models that you saw me use earlier, and many, many more that are available to use. These are available on this website, and if you click on any of those, it will take you through to our GitHub, which has even more models to explore. Our GitHub code is available at this link here, and of course, Tensorflow JS is completely open source. So if you want to contribute, please do. Our code is open source on GitHub for the core TensorFlow JS library as well. And then we have a Google group. If you have more technical questions, both myself and the team, all the software engineers on the team are monitoring that Google group from time to time too. And then finally here we have CodePen and Glitch, where I've created some boilerplate code to get you started from a working point. So if you want to try things like the body pix model you saw, the object recognition, that kind of stuff, I've made some boilerplate code you can just take and run with for like the webcam and click on the images, so you can get that for free, and then you can concentrate on making something cool using those models. And then the final thing here is for those who want to go deeper and really learn machine learning properly, there's a book called Deep Learning with JavaScript that is written by the TensorFlow JS engineers and also the TensorFlow engineers at Google, along with some other folk. And it's a really good book. It can take you from zero knowledge in machine learning to understanding how convolutional neural networks work and GANs and all this kind of fun stuff, which is very, very robust book to take your first steps with in JavaScript, of course. So if you're coming from Python land to JavaScript, this is also a great way to learn the differences in how to use the TensorFlow JS stuff. And honestly, it's not much different, but you need to just get used to the JavaScript syntax and the various functions you can call and some of the benefits you can get when you call those functions. And with that, I invite you to come join our community. If you search for Made with TFJS hashtag, you can actually find tons of projects people like you are making already. Some of them are also complete beginners of machine learning, but just look at some of the things people are creating here on this slide. So I hope to see contributions from you soon. And if you do use that hashtag, there is a chance that you'll be featured at our future TensorFlow JS show and tells. And of course, when we have the ability to make conferences in the real world again, maybe we'll invite certain folks to come talk about their project there too. So that I just leave you with final thoughts. What will you make? And there's one final piece of inspiration here. This guy from Tokyo, Japan, he's actually a dancer, and he's managed to make this really cool hip hop video using TensorFlow JS. And this just goes to prove machine learning really is now for everybody. It's not just limited to the researchers and academics, but the artists, the musicians, the creatives can now use machine learning too. And I hope TensorFlow JS is one of the tools you can use to make that possible and make it easy to use. And hopefully, if I do my job correct as developer advocate, I'll make things that make it easier for all of you to get started with TensorFlow JS too. So I do welcome feedback. If you start using TensorFlow JS, please come and talk to me. And with that, I'm available on Twitter and LinkedIn for further questions if your question isn't answered today. And I'm happy to connect over there. And of course, I post lots of cool stuff about machine learning generally, JavaScript, design, UX, all these kinds of areas. So please do come and connect over there too. And with that, I'll hand it back over to the presenters for any questions they would like to pick.
All right, Jason, that was so lightning and magnificent talk, and I hope that your talk inspired our viewers a lot to learn machine learning. So, beginning with the questions, there's a question that Uh, as you mentioned the single board computers in the beginning, which will you prefer personally to code Python or JS, as both are supported and we have memory and processing limits?
For a single board computer, it depends on what you want to run, essentially. If you're using something like the Raspberry Pi, we've got people at IBM already using Raspberry Pis to do some amazing things, and they're running TensorFlow JS via Node.js on the Raspberry Pi, because Raspberry Pi just runs Linux, essentially. That means you can install Node, and therefore you can load any of our machine learning models to run in the Node.js environment too. So I'd encourage people to try it out and see how the performance is. Obviously, for these kind of edge devices, you want to have small models that are speedy. So when you are training these things, you might want to optimize for that to give it the best chance of running at a decent frame rate. But we've seen people do object recognition on things like a Raspberry Pi and get good results, so they can control things in the house. When they recognize someone walking in through the door, they can actually then control a servo to do something or whatever it might be. So this can definitely work on things like Raspberry Pis.
All right, that was great. And another
Yeah.
question, which yes, of course, you can.
Yeah. So actually, I had two questions. Firstly, the session was quite insightful and the visualizations were really brilliant. So my first question is like, it's basically a follow-up question to what just Mayank asked. So let's suppose like for research purposes, what we do is like we do a lot of training on different models, checking the efficiency and stuff. So you showed a slide regarding the speed of the training. So what do you believe, like how efficient is like training a model on TensorFlow JS in comparison to like if we train on Google Colab?
Sure. So I guess it depends what environment you're using, right? So if you're using server-side with Node.js, TensorFlow JS implementation, it's basically the same as Python because we're talking to the same C bindings as Python. So the performance, as you saw from the graph, is the same or better for the pre and post processing when you're actually using the model as well. So we've got parity there with Python. If you're talking about the client side, then of course it depends on the machine that you're running on. If you're running on a very old laptop with no graphics card, then of course you're not going to get graphics card acceleration because there's no graphics card on that device. So that will depend on the device you're running on. I encourage all of you to try out things like Teachable Machine to get a feel for how well it can perform on your device. And you can then adjust accordingly to change how you use that machine learning model. And you might want to kind of prune it to make it more lean so it runs faster on older devices. But honestly, a lot of the models you saw today, like the face mesh one, they're tiny models, like 3 megabytes in size. And I run these on my mobile phone from 2 or 3 years ago, and I still get like a decent frames per second to be able to do something useful.
Yeah. Another question, like this not a technical one, but like I recently saw your post on LinkedIn, the SpaceX project, the Dragon. You mentioned like
Yes.
the Chromium was used and
Indeed.
JavaScript. So did TensorFlow JS had any role in that project?
I don't think we were around when they started coding that, unfortunately. So I don't believe we're used in that. That was just a shout out to JavaScript generally to show how versatile it is and how wonderful it is from its humble beginnings, like many years ago, to now being used in these space projects. It's really amazing to see how far JavaScript has come. And a lot of people kind of were talking about that tweet, and they were like, "Oh, is it really being used? I don't believe you." And just recently, the SpaceX engineers did a Ask Me Anything session on Reddit recently. This is just a few days ago, I believe, and they did confirm that they're using Chromium, JavaScript, and web components in their build for the rocket, which is pretty awesome. So yes, JavaScript is very powerful. It's not just a toy language that some academics might think it is. It's very powerful, and used in the right way, as with any language, you can use it to make pretty much anything.
There is one more question that how So how to implement the Python ML libraries in JavaScript? Is there any really built-in library for this in JavaScript?
So as far as I'm aware, the only library that runs in JavaScript right now is TensorFlow JS for TensorFlow. I'm not aware of anything in like PyTorch and other things. And I guess that's one of our unique kind of points of using TensorFlow is that we do support the web and all the environments that JavaScript runs in, as you saw at the beginning of the presentation. I'm sure with time, other things might come up, but to the best of my knowledge right now, we are the only ones but I'm aware of at this point.
Okay, and one hot question that we are having right now here is that how can we learn about Node.js from beginning? I mean, the resources, the books, or any. So is there any course or something like that you would like to put up?
There's many courses on Node.js and JavaScript, generally speaking, on many of the popular sites that you probably already are aware of, things like Coursera and Code Academy and all these kinds of sites. In fact, Code Academy is free, I believe, so you can try some of their courses for JavaScript for free. So it's a great way to take your first steps with the JavaScript language. And of course, if you know JavaScript, it's very easy to transfer that knowledge to Node because Node is just JavaScript with some extra function calls so you can access the file system and other things. So you can transfer that knowledge very, very easily. And that's one of the reasons I personally love JavaScript for prototyping is that I can use it on the front end, on the server side, on native apps, on desktop native apps, on Raspberry Pis, and you can reuse your code, which is super, super useful. So yeah, it's very easy to pick up, I think. And that's why 67% of people use JavaScript is because it's very easy to start tinkering with and develop with.
Oh, that's a great number. How do you think that deep learning can be employed to the future of space tech?
That's a better question for the SpaceX engineers. That's not my realm of expertise, unfortunately. You'd have to have a session with SpaceX engineers for that one.
All right. So can you please brief about TensorFlow Quantum? I mean, what are the add-ons to existing TensorFlow libraries for Quantum ML?
Once again, that unfortunately is outside of my expertise. My role is only TensorFlow JS, so I have nerded out a lot on the JavaScript TensorFlow. But TensorFlow Quantum is definitely, it's coming. It was announced, I think, recently, but I don't know enough about that to give a good answer. But quantum computing generally is a very interesting research area. Of course, there's many caveats with using quantum computing. It's useful for certain things over others. So I will have to defer to the quantum team for answers on that one, unfortunately. But I'm very excited to see where it goes, and hopefully there's a similar session like this that I can attend in the future to learn more about quantum.
That's good for us too.
Yeah. So another question is like, what's the scope of using C++ in like using the TensorFlow with C++?
I mean, I believe TensorFlow was written in like the C language, so it shouldn't be too hard to then be able to run it in this kind of environment. But once again, that is a different team. I am only responsible for the JavaScript side, so I'm not familiar with how the other people are using it right now in other languages. My role at Google is only to focus on the JavaScript side.
All right, so is there any Android port available for the TensorFlow libraries?
So there's TensorFlow Lite that can run for with an Android apps themselves. But as I also mentioned, you can also use React Native with TensorFlow JS if you do prefer to use JavaScript to get native applications using TensorFlow 2 using the JS variety. So you can choose TensorFlow JS or you can choose TensorFlow Lite. Those are your two options for mobile, essentially.
Oh, all right. So one of our viewers had put up a question on the comment box. I don't exactly, I mean, I cannot say that it's a question or not. So it's like, it goes like it. A question struck in my mind that the files that are stored in the JSON format, they are named after your name. Since Google was the first to introduce the same, so I thought that maybe you are behind it. Kindly confirm.
No, JSON is actually a common storage kind of mechanism in JavaScript. It's called JavaScript Object Notation, essentially. So that's what JSON stands for, even though it's one letter away from my name. And I do sometimes get called JSON for fun at work as my nickname. It was not because of me that they called it a .json file. That'd be very cool if it was, but unfortunately not.
Thank you so much, sir, for that wonderful session and that enlightening Q&A session. I'm sure that was an amazing experience for all of those tuning to this session here today. On behalf of the organizing committee of IEEE Chandigarh Subsection Congress, I hereby extend you our deepest gratitude for gracing us with your presence in this Congress. We wish you all the best for all your future endeavors, sir, and hope that you continue to inspire and motivate us to excel in the field of machine learning.
Well, thank you very much for having me today. And again, feel free to connect with me on LinkedIn or Twitter for anyone who wants to ask any further questions. Cheers.
Thank you, sir. One important announcement for all those tuning into YouTube live right now. The quiz has now been rescheduled and will be conducted tomorrow at 5 p.m. positively. I repeat that the quiz will now be conducted tomorrow at 5 p.m. positively. So with this, we wrap up day one of the first ever virtual IEEE Chandigarh Subsection Congress. We have an equally exciting lineup of speakers for all of you on day two. This includes the Chief Technology and Chief Science Officer of Hanson Robotics, Mr. Amit Kumar Pandey. By the way, Hanson Robotics is the same company which made global headlines when it developed the world's most advanced robot, Sophia, about which I'm pretty sure you all must have heard. So Mr. Pandey will be delivering a session on AI and robotics, which should be pretty exciting considering he's the man behind Sophia. In addition, we also have the case study presentations kicking off at 2:30 p.m. and the code bit lit competition at 8 p.m. with exciting prizes for winners in both. We are pleased to say the least with the positive response this Congress has received in terms of the number of registrations and participation. We hope that all of you had a positive experience with day one of the virtual Congress and are as excited for day two as we are. Thank you all. Good night and see you tomorrow.
Mukul, just a minute, sorry to interrupt. Can we just have a photo? You guys just can on your video, can share your video.
Yeah, sure.
And we can just virtually only. Done. Thank you.
Thank you so much. Thank you so much, Jason sir.
Thank you, sir.
Bye-bye.
Thank you for your
Thank you,
time.
sir.
Bye.
Bye-bye.
रुक जाओ अब मतलब बात रुक जाओ जिन वॉलंटियर